corresponding. So if you have a look at this image, open a new image in new tab. This is an image for leading and lagging case. Okay, let's just paste it on here. A bit large. Okay. So here we have the representation for two different objects undergoing with same angular speed about a circle. So what we have over here is the blue arrow is a bit longer in length and the red arrow is a bit smaller in length. So whenever they are going around the circle, they are making the omega t versus vertical height graph that looks somewhat like that. So whenever both of them are perfectly aligned and they are undergoing circular motion with the same omega, we have the exact same phase graph. That's what I see over here. That which means all the crests are. That means that all the crests are perfectly aligned. All the troughs are perfectly aligned, and essentially the waves have the same time period. Obviously, because they have the same angular speed. So this is what we call to have a zero phase difference, which is very simple to understand. Now, whenever these two particles, these two arrows or orbiting arrows would not be being aligned with each other. If they have two different places, they would still go anti-clockwise direction with omega speed. But what if they are not aligned to each other? Then how is it going to look like? This is one of this example that is shown over here. In this case, this rotation is happening in such a way that the blue arrow and the red arrow, they have an angle between them that is this much. Let's say this angle is somewhat less than 180 degree. Now I have a reason to explain this in terms of 180 degree. I'm gonna bring that up a bit later. Because this angle is less than 180 degree. So what I want you to visualize that these two arrows are gonna maintain that same angle between each other, and they're gonna keep on rotating like that. So come to think about it, if you consider the phase angles on this circular motion are fixed, let's say this is your 0 angle location, this is your 90 degree location, this is your 180 degree location, this is your 270 degree location, and this is once again your 0 degree location or 360 degree location, and the whole cycle repeats itself. If you try to physically think, whenever they will rotate, when the blue arrow would go past 0, red would still be this much angle behind to reach the starting point. When red would reach the 0 point, the blue arrow would have moved by this much angle and clockwise on the other position, which means for any instant, because of the angle that exists between them, for any instant, apparently blue is achieving that angular position earlier, and the red arrow is achieving that same angular position a bit later, slightly later. That's why we say that the blue arrow is leading the red arrow. Do you understand this point? In physical term, the same position is achieved by the blue arrow earlier compared to the red arrow. এই আইডিয়াটা কি বুঝা যাচ্ছে কিনা?
Yes, sir.
আচ্ছা, এখন you might wonder that why did I bring about the idea for 180 degree over here? Because it's important. Whenever if I say that, let's say this angle over here is maybe how much? Let's say this total angle between red and blue is, let's say 100 degree. I'm just choosing a number, 100 degree. So if I write the equation of the red as maybe sine omega t, then the equation for the blue, which I could actually write in red. Where is the red color? Where is the red color? If this is sine omega t, and then the other equation for the blue, which is bit ahead of the red line, that should be written as sine omega t plus 100 degree. That's the key equational difference, difference in the expression of equation in terms of the two different expression. Other way, we could also write this one, the blue, if we wanted to write the blue one as sine omega t, then the red one should look like sine omega t minus 100. This both mean the same thing. This means the one that has a bigger positive angle added with itself, it means that this one is leading this one by 100 degree. Now, leading a certain motion by 100 degree is for a repeated motion, for a circular, for a periodic repeating motion. This expression is sinusoidally equal to this expression as well. This is what the part that I need you to understand. If you just plot two graphs of sine theta plus 100 and sine theta minus 260 degree, you'd pretty much end up with the exact same graph. Now, this is the part that I want to show. This is because the actual phase angle between these two expression is only 360 degree. Let me convince you of this fact so that you can actually believe me. I'm not going to draw this manually, so I'm going to use Desmos to show you the drawing of this thing. Actually, do one of my other graph here, so I'm just going to have another instance open here. So this is y equals to sine x. I'm using the number 100 over here because I wanted to, for the x-axis to look like in degree, so that you can actually make sense that at 90 degree we have plus 1. If I just give it only 1, the y-axis actually become very small. So that's why I didn't do it. Or I could put it in radian, then the graph would look more realistic. But just to have a convenient known shape of the sine curve, I'm choosing to give this 100. Now, if I want to change this graph, let's say if I write x plus 100, you see, what you'd see that this starting point has gone left by 100. So whenever you are making the graph to get a bit leading situation, for example, I can write, have a look. If I write 1, you have it moved a little bit. If I write 10, it is moving a little bit more. If I like had 100, maybe if I write 20, you have this much left movement. Then if I write 20, you have a bit more left movement. If I write 30, you have a bit more left movement. So the bigger angle that you write, the more the wave moves to the left. It means that this wave is leading. Having a plus addition with the graph means this was a leading wave. That's why if you have two waves overlapping in a certain figure, ideally the one's crest for pair vision means if you have a look over here, that you should see that these two crests are close to each other, or these two troughs are close to each other. And if you observe the sequence between these two behavior, this blue crest appeared to be earlier than the red one, and here the blue one appeared to be earlier than the red one. So this is why we are calling that the blue crest or the blue object, blue arrow, is leading the red arrow or the red curve by whatever the angle difference between these two positions on the x-axis. That's the angle, amount of angle. And the point that I'm trying to show you over here, I'm going to make my point over here. So if I write x plus 100, and this is the graph that you get. If I write another equation, let's say y equals to 100 sine x plus, no, not plus, I mean to write minus 260, you'd get the exact same graph. You see, there is no existence of two different graphs because they're overlapping onto each other. If I select this one, you're going to see the red one. If I select the blue one, you're going to see the blue one, because they are the exact same graph. They're overlapping onto each other. The point that I'm trying to make, that they are the exact same graph, which means any graph which is leading by 160° can be also said to be lagging by 260°. Now the question is that which one should we use? Which one should we preferably use? Either of them can be used. It all depends upon the situation, that how the examiners or the person who is writing about the leading and the lagging scenario, which one they prefer. Both of them are, both can be used, but usually the most easier way to visualize it, if we keep this angle smaller than 180°. That's where this idea is coming by. I mean, whatever the angle that you write for after plus or minus, let's say you have this, let's say this is your standard angle, and then you are trying to give a standard curve, and then you are trying to give a new wave which should be expressed by something added with omega t plus or minus theta. So this is the leading or lagging curve that you want to express with respect to the original graph. It is convenient to visualize the graph if we keep this theta value at a value lower than 180°, because that actually gives us a bit more easier visualization. So let's say if I write, let's say sine omega t plus 120°, this would mean that this graph is going to be, the crests are going to be on the left of the original graph by 120° earlier. And then again, if I write sine omega t plus minus 120°, this would mean that this is the lagging graph, which would be belonging on the right side, or they would be happening a bit later compared to the original graph. So keeping the angle less than 180° actually makes it easier to visualize, but because angles are a repetitive thing, 0° and 60° at the same angle, so expressing the same angle in this fashion can also perfectly work. এই পার্টটুকু বুঝা গেছে কিনা, because I'm going to get back to the piston example right now, but do you have any question about this thing up so far? Anyone? Maybe not. আচ্ছা, আমি এখানে বেসিক্যালি তিনটা গ্রাফ আঁকছি। এই তিনটা গ্রাফ আঁকছি হচ্ছে তোমাদেরকে বোঝানোর জন্য যে আমাদের ওই প্রবলেমটা সলভ করার জন্য আমাদের কি লাগবে। সো I'll pick up that thing. এটা যেন কোথায় আছে, হচ্ছে ড্রাইভ টেস্ট। শেষের দিকের একটা কোশ্চেন, as far as I remember. This one, question number 22. This is the question that we had. So the point that I got stuck at was to draw the possible position of the Y piston and the Z piston with respect to the X piston. So this is the part that I want you to understand. If you understand this, you'll be able to visualize this much too easily for your own personal for in the example as well. You wouldn't need to draw that graph. I actually went to drawing the graph to explain, but I hope you wouldn't need that. Try to have a look. This is the situation for cylinder X, which is at the lowest most position. So we can write this as a minus cos curve. So in my Desmos graph, I have drawn the red one as my minus cos curve. So this is my X. I don't know how to label these graphs over here. Can we label these? I really don't know how to label these. So just remember that the red one is the uh, x-axis graph. And then the question says that why should be the piston which is leading this one. Have a look over here. In cylinder Y, the oscillation of the piston lead those of piston X in cylinder X by a phase angle of 120 degree, which means these particles underwent this position 120 degree earlier. Leading means physically these things are 120 degree ahead of AB. So the position that AB is at, this piston is gonna be 120 degree ahead of this piston. Now that's the part that I need all of you to understand. This is your lowest position, this is your highest position. Let's say this is your mean position. So if I want to divide this thing into different degree position, let's say this is 0, this is 90, this is 180 degree, this is 270 once again coming downwards, and this is once again 360 degrees. So that's the degree variation. Piston AB is right now at the lowest position. Piston Y was in the lowest position 120 degree earlier, which means currently it should be 120 degree forward of piston X position. So 120 degree forward means what? It should be 120 degree far away from the starting position. So this is where piston Y should exist, between the 90 and the 180 degree mark, 120 degree mark, and the direction of motion for this instant should be upward, because it is only 120 degree leading. It is not 180 degree leading. If it was 180 degree leading, then it would be perfectly over here, stationary. Because it is 120 degree leading, it means now the motion of this piston should be going upwards. We actually could find out the position of the piston Y last class properly, but I messed up the direction, velocity direction, because I messed up the concept of leading and lagging. Happens pretty much every year. I go through this whole discussion and then I forget, then I refine that, and then I reteach that. But anyway, so this is why Y should be going upwards. If you want to have a visual proof from the graph as well, this is what I can show you. Have a look. Red was the graph for the X, and plus 120 degree means 120 degree leading. So blue would be the graph for Y. Have a look. What is happening at 120 degree mark? This is your 100. This is your 120 degree. At 120 degree, exactly. I was messing up a little bit. I'll tell you what did I mess up. I was trying to observe the position of the blue graph at 120 degree, but I'm not supposed to observe the position at the 120 degree. You have to understand that in this case, this x-axis is the time axis. This is the time axis. So we have to observe the position of each individual graph, blue, green, or red, at this point along this line at t equals to 0, because we are asked to find out the position and the velocity direction of the y and z piston when exactly at the instance when x is at this position. So I'm not supposed to look at different time instances, rather I'm supposed to look at the same time instance. So this is why if you observe over here, the red is the graph for the x piston, and when red is at the lowest position, the blue graph is actually over here. You should see that this is at 3/4 above the lowest position, or at the exact half point of the upper half. And you can see that the gradient of this blue graph is actually positive. A positive gradient, essentially a positive graph of the displacement time graph, essentially means positive velocity, which means the object is now going upwards. And vice versa, if you consider for the 240 degree, it basically means 240 degree leading basically can mean in vice versa can mean that 120 degree lagging. So that should be going downward. So both blue and green should be at the same level, and blue should be going up. So in this case, y should be going up, and The other part is also quite simple. I'm gonna explain the Z part with a different color. But my question is, did you understand this discussion for the Y piston? That Y 120-degree leading means that position and that direction of velocity. Does it make sense? কোন question থাকলে বলো, I'll help you understand. Anyone? আচ্ছা ঠিক আছে। Z এর কন্ডিশন হচ্ছে in cylinder Z the oscillation of the piston lead those of piston in cylinder X by phase angle of 240 degree. তো আমরা এখন যে কাজটা করব সেটা হচ্ছে আমরা এখান থেকে 240 ডিগ্রি লিডিং মানে হচ্ছে 240 ডিগ্রি আগে এই পিস্টনটা কোথায় ছিল, সো এইটুক পর্যন্ত নামলে হয় হচ্ছে 180 ডিগ্রি। সো তার মানে হচ্ছে পিস্টনটা 240 ডিগ্রি, সো এটুকু হচ্ছে 180 আচ্ছা দাঁড়া হল, এটা হচ্ছে আমাদের 270, এটা হচ্ছে 180, এটা হবে হচ্ছে আমাদের 240 ডিগ্রি পজিশন, এটা হচ্ছে 270 ডিগ্রি পজিশন। You might wonder যে এটা ইকুয়াল কেমনে হলো, এখানে হচ্ছে 60 আর এখানে হচ্ছে 30 ডিভিশন, because I showed you the earlier class that cos 60 ভ্যালু হচ্ছে সরি cos 60 ভ্যালু হচ্ছে হাফ আর sin 30 ভ্যালু হচ্ছে হাফ। So closer to the x-axis you have a bit more, I mean closer to the smaller angle you have a bit more variation of magnitude. So this should be over here, this object should be over here, and this object should be in this case going down. If you wonder how is it going down, let me show you a 240 degree phase covering of this object from this position to this position. How 240 degree phase would be covered? This object would go down, and this is over here, this is over here. Oh yeah, makes sense. uh the uh the reason I'm telling to tell you the reason I suddenly to say it makes sense, because the motion that we're trying to perceive over here is that with respect to this one's motion, the position that it is at, this level was at this position by covering this much distance, whereas this level came up to this position with respect to the x-axis position by covering all the way up and then falling from here this much distance. That's where the 240 degree comes in. That's how the difference is shown. So if they told us that it was not a phase angle of 240 degree, leading of 240 degree, rather if they told us that this was a case of lagging of 120 degree, that might have been easier for many students, that they would give just opposite direction, but could be able to maintain the same level. But they didn't do that because they wanted to check the understanding of the students for some reason. But this is how it works. These type of questions can prove to be a bit difficult because they're not so common. They're quite a bit rare in terms of your past year question papers. But if you ever forget that how does leading and lagging work, always try to remember that if you have a piece of graph, the leading should be on the left side and the lagging should be on the right side. So if you're trying to draw, let me just help you show you how can you draw a leading or lagging graph easily in the exam hall for if ever you need it for some decision making process. So let's say I'll realign myself. Let's say this is your axis system, okay, and you're now for some reason you're trying to draw the graph. So draw up the axis values well, 90, 180, 270, 360, and then maybe 90, 180, 270, 360. Let's say I'm gonna maintain my graph over here, and I'm gonna use these two positions as my maximum minimum position for the sake of convenience. So if you are trying to draw a leading graph, for example, let's say you have a sine graph, y equals to let's say sine theta. So that graph is basically gonna look like that. Try to complete one full cycle, because that would be convenient for you to judge for the other parts as well. So this is how your one cycle of sine theta angle should look like, and it should be reverted on the left side as well. I could draw that, but let's say I'm not drawing that. Now if you are trying to draw a graph of y equals to sine theta plus 50 degree, let's say 50 degree, what you just have to do, you have to shift this entire curve. You just have to shift this entire curve. Can I not select both of these together? Apparently I cannot. Okay, you just have to shift this entire shape of the curve 50 degree to the left, which means this crest will be located 50 degree to the left. This cross point should be located 50 degree to the left. This axis cross point should be located 50 degree to the left, and everything should shift to the left. That new graph would look somewhat like this. And if you are trying to get a graph that is lagging, which may be expressed by, let's say, sine of theta plus, not plus, lagging should be given by minus, let's say maybe 70 degrees, choosing a different value. Sorry, I messed up the color. This is this, and now we're trying to draw this one. In that case, all of your points should be moving 70 degree from the respective position. So you just choose a point 70 degree over here, choose a point 70 degree over here, choose a further point 70 degree over here, and then you just draw the same sine curve. This can actually help you to understand how this happened. And if you're trying to observe the position of the all the graphs at one time instant, you have to look at the starting or along one vertical line, that how the particles are working at a certain time instant. So that's pretty important. You shouldn't I mean, when you are drawing the graph, you have to shift them by means of their phase angle. But whenever we will observe how would the physical objects look like at any instance of time, you have to observe the graph positions for one vertical alignment. That gives you the instance position for one single time value. এই drawing procedure কি বুঝা গেছে? How to shift the graph and everything. তোমাদের এসে ছিল, ওয়েব চ্যাপ্টারে ছিল, but still having a quick recap. Many of you might have forgotten, so small brush up is never hurting. So that's that for this question that we were stuck at in our last class. We'll move on from this question. তোমরা কি কিছু try করছো? Do you have any questions that you would like me to discuss from this worksheet?
Sir, 27, I lost it.
Beautiful. We'll have a look at that. 27. এটা
27, I lost it.
আচ্ছা sorry, I'm 25, my bad. So 27 is a good question. 27 number question আমরা একটু দেখি সবাই. Question says define simple harmonic motion. এটা লিখবা, বলেন good. দ্বিতীয় বলছে horizontal plate is vibrating vertically as shown in figure 3.1. Vertical oscillations, frequency 4.5 hertz. Cube mass 5.8 gram. There is a plate. The plate undergoes simple harmonic motion with a frequency of 4.5 hertz and amplitude of 3.0 millimeter. A metal cube of mass 5.8 gram rests on the plate. Rests on the plate means it is now in contact with the plate. The plate is undergoing vibration. The metal cube is resting on the plate means the metal cube is also undergoing simple harmonic vibration along with the plate. Now, the question for this is calculate for the cube the energy of the oscillation. So that is just half m omega square a square. You just calculate that out. In number C, it says the amplitude of the oscillation of the plate A is gradually increased. The frequency remains constant. So important information. We're keeping the omega same. We're increasing the A. At one particular amplitude, the cube just loses contact momentarily with the plate. At one particular amplitude, the cube just loses contact momentarily with the plate. State the position of the plate in its oscillation at the point when the cube loses contact. Calculate the amplitude of oscillation and what should be the amplitude of the oscillation. So we have to judge that. So let me help you understand by elaborating this scenario. I might as well actually. এখান থেকে তো আমি কাটতে পারবো, হ্যাঁ কাটতে পারবো। আচ্ছা, এটা আমার মনে হয় পেন্টিতে দেখাতে আরাম হবে। দূরও সেখানে দেখেন। Why does it lose that alignment very so fast? আচ্ছা, যাই হোক, মনে করো এটা হচ্ছে আমাদের কিউবের মোশনের তিনটা ডিফারেন্ট স্টেট। লেটস সে দিস ইজ দ্য ইকুইলিব্রিয়াম পজিশন, this is the highest position, this is the lowest position. Now, couple of things that I need you to understand and appreciate. First of all, this cube would be moved by the effect of two individual forces. One is the weight of itself, the other one is the reaction force that it receives from the plate. Ideal case, if the plate was not oscillating, if the plate was stationary and the cube was also stationary on the cube on the plate, then W equals to R, you have zero resultant force, so on and so forth. But because the plate is now moving up and down, there would be a scenario of simple harmonic motion. Now try to understand that the core idea for simple harmonic motion is that acceleration is proportional to minus x. This acceleration basically leads to resultant force of the object. Resultant force equals to mass of the object into acceleration. And resultant force in this case would be coming from some variation of W and R for this object. Now W itself is a constant. Now because the acceleration has to vary with respect to the displacement, acceleration has to vary with respect to displacement. I mean, when the cube is above its equilibrium position, the oscillating force should be working downwards. When the cube is below the position, the oscillating force should be working upwards. That's the whole idea of simple harmonic oscillation. You have your acceleration always working towards the equilibrium, or the acceleration always works in the opposite direction of displacement. So now what we need to judge that this is the position of the cube, and we'll have the same value of weight for every single instance. Now try to judge. If we consider the two terminal positions, you would have the maximum requirement for this force. So let me just drop this force by red. So let's say the maximum value of this force you're going to need over here is this much. The maximum amount of resultant force you're going to need to maintain simple harmonic motion over here is this much. These are two values of maximum force, which can be mass into acceleration, which is m omega square a. Now this resultant and this resultant force, they should be coming from W and R. If I try to draw the W force in different places, it is possible. I mean, W would be always working downwards. So in this case, let's say I'm going to drop a large W first, and I also want to draw a large W over here as well. So I'm drawing up large W's just to make things from the beginning. drawing up a large W essentially means, large W means that your weight is bigger than the maximum requirement of force. You have to see that this resultant force, I mean, in for the let's go one by one. For the top position, the resultant force is working downwards. The weight is also working downwards. If there is a bit of a difference, for example, in this case, the required resultant force for to maintain simple harmonic motion is somewhat smaller than the weight, which means all the weight that the cube has by virtue of the gravitational force, it will use a small portion of that force on a significant portion of that blue arrow. I mean, this cube will use this blue arrow, a part of that blue arrow, to maintain SHM. And the remaining force that you have, which I might label with green, let's say this is the remaining amount of force that the object cannot use for SHM. So it will exert that much force onto the table. And by Newton's third law, you are gonna only get that much reaction force onto the cube in the upward direction as well. So the cube applies this much remaining force on the table. This is the force from the cube on the plate. And by Newton's third law, the plate will also apply equal amount of upward force on the cube. So this is the force that the cube applies on the plate, which I don't want to draw. I just drew this to give you the idea that where this extra force will go. So I'm gonna rub that. The cube would be also subjected to the remaining amount of upward force. So what is happening over here? The sum of blue and green arrow is giving you the resultant of red. এই আইডিয়াটা বুঝা গেছে কিনা?
Yes, sir.
ঠিক আছে, কার কোনো কোশ্চেন থাকলে বলো. This is what happens. And on the lower side, the situation is quite different, because in this case, the weight is working downwards, but you need your resultant force working upwards. So in any case, at the equilibrium situation, if I want to draw this for the equilibrium situation, at the equilibrium position, you don't need any resultant force. So the red arrow simply doesn't exist. So exactly at the equilibrium position, your blue arrow and your green arrow are exactly equal to each other. Why? Because weight is a constant and weight has to be perfectly balanced by the reaction force, so they will be perfectly equal to each other. So if you just have a look at these two figures, what you see that the weight is remaining the same. So basically what I can write that considering the upward forces and downward forces, the resultant force would be given by the what can I write? By reaction force minus weight. Yeah, reaction force should always work upwards. So I'm considering upward forward direction as positive. So in this case, this is a positive force, this is a negative force. I'm not very comfortable writing the vector equation in this manner, but what I want you to understand, the resultant force will be coming from the reaction force and the weight, and they are vector quantities. Now when at the equilibrium position, these two forces will be perfectly equal. The object doesn't have any resultant force because it doesn't need any resultant force to maintain motion. When the plate is gonna go beyond the equilibrium position, then what's gonna happen? Then the required resultant force is gonna be in the upward direction, but the weight is still gonna work in the downward position. So you would require a much bigger green arrow length so that your resultant force is actually significantly. All of these arrows should be in the same alignment. I'm drawing them in different elements so that I do not cover them up. So what is happening over here is that you want to have the upward arrow, which is the resultant force, and that is coming from the subtraction of the big reaction force from the plate minus the constant weight of this thing. So this thing is giving you the resultant force over here. So the reason I'm trying to explain this in a visual form like this is that I want you to understand that this reaction force is actually undergoing all the changes to bring about the change of the resultant force. Weight is always remaining constant. Now, this essentially tells you, you have to understand that the existence of this reaction force that the object receives from the plate is basically because of Newton's third law. The object can only get this much reaction force if the object pushes the plate by that same amount of force. That's Newton's third law. I mean, the cube has to push the plate by that much big force to achieve that much reaction force back. So which means for this lower position, your reaction force will be always by magnitude bigger than the weight. Not necessarily. No. Yes, necessarily. Below this position, your reaction force will always be bigger. Below this position, your reaction force will always be bigger, because you will require some acceleration. Some acceleration would come from some force. So below this position, exactly at the equilibrium, your reaction force and weight are equal. Here at this position, your R equals to W. Below this position, R is definitely bigger than W. Now, what is happening on the upper position? What you need to understand that when we are gonna start to increase the amplitude of the motion, have a look over this one. The centripetal force is given by, not centripetal force, I mean the equation for circular motion is equally applicable for simple harmonic motion as well, that we have derived earlier. So F equals to m omega square R, and I can write F max, the maximum force, would be m omega square A. So if we slowly start to increase the amplitude of the particle, the F max will also increase. This is basically, I'm talking about the red force. So I should have written this in red. Consider this all written in red. So the resultant force, maximum resultant force that we're going to require should be coming from m omega square A. Now, as the object starts to have bigger and bigger amplitude, the length of this red arrow is gonna slowly start to become bigger and bigger and bigger and bigger and bigger. So there would come a certain point for a certain height of the object, for a certain amplitude of the object, when this resultant force requirement and the length of the blue arrow, they would be perfectly equal to each other. This is the situation. This is the situation where the object will use all of its weight to maintain simple harmonic motion. It means it will no longer push on the plate any further. Get the point? This is the situation where all of the weight will be required to maintain simple harmonic motion. The cube will no longer push on the plate. This is the earliest onset of what we call weightlessness, that there is no reaction force. Weightlessness is the scenario where you have no reaction force. You have used the weight for something else. That's why you don't have any reaction force. That's the situation that we call weightlessness. And if we have the plate oscillating, at this point, we still see the cube being in contact with the plate. But if we increase the amplitude of this motion even slightly higher than this value, let's say this is happening at A amplitude, then we would practically see the moment the plate reaches the highest position, we would see the cube take a small jump of the plate, and then it will land on the plate once again. That would be the case of leaving the plate. That would happen when the weight would not be able to keep the cube in contact with the plate, because you would require a much bigger amount of centripetal force, not centripetal force, I mean resultant force at the highest position to make the motion ongoing. Your F max value would become simply higher, so you would require the particle to rise even further above. বুঝা গেছে কি?
Yes, sir.
কোনো question?
No, sir. Thank you.
Sure. So আমি ছিলাম কোথায়? আচ্ছা এখানেই তো ছিলাম, শুধু শুধু ঘুরতেছি। So we were right over here. So the question that they're asking about, how are you going to write this answer? The question they're asking that at the amplitude of oscillation of the plate is gradually increased. The frequency remains constant. One particular instant, the cube just loses contact momentarily with the plate. State the position of the plate in its oscillation at the point when the cube loses contact. Although they have mentioned the position of the plate, and they still have given us two marks. So I am not sure how does a state question can have 2 marks. I would write at the maximum amplitude position above the equilibrium position. I think that should work. I'm mentioning the maximum could score you 1 mark, and mentioning the above should give you the other mark, I believe.
Yes, sir. You show maximum at maximum displacement above rest position.
আচ্ছা, মানে maximum ওয়ার্ডটার জন্য 1 মার্ক আর above এর জন্য আরেক মার্ক. This is the 2 marking words, right? I believe so. আচ্ছা, number 2 তে বলছে calculate the amplitude of this oscillation, and calculate the amplitude of the oscillation calculate করার mechanism খুব simple. We simply have to write that W equals to m omega square a. এখন এই ওমেগাটা আমরা ইজিলি বাই করতে পারবো. আমরা একটু আগে ফ্রিকোয়েন্সি বের করছিলাম, ফ্রিকোয়েন্সি মনে হয় দেওয়া ছিল, কোথায় ফ্রিকোয়েন্সি ছিল 4.5. সো ওমেগা ইকুয়ালস টু 2 পাই এফ এখানে বসাবা. W তো অলরেডি আছে, সো W ইকুয়ালস টু হচ্ছে mg. You don't have to bother to write the replace the m. You can write mg equals to m omega square a. Mm crosses out, so all that you would have to write is 9.81 equals to omega হচ্ছে 2 pi f, তার মানে হচ্ছে 2 into 3.1415 into 4.5. This is your total omega whole square multiplied by a. তো এখান থেকে এখন তুমি বের করে দেখো যে a এর ভ্যালুটা কত আসে, দেখো তো মিলে কিনা. You can use the calculator pi value. You don't have to write 3.1415. Using the calculator pi value is equally acceptable.
One point two ten to the power minus 2.
মিলছে?
Yes, sir.
আচ্ছা, মার্কসিং দেখছো?
হ্যাঁ।
আচ্ছা, beautiful, thank you. Okay, this is a good question. It was a worthy of discussion kind of question, because this actually give us an idea that how the motion is gonna vary whenever this will happen. This is also a quick hello. This scenario that we just discussed over here. It has quite a bit of similarity with the question that we discussed in our circular motion chapter, where on a horizontal disk we placed a small cube object and we are trying to rotate it faster, and we tried to explain that at a certain point this will start to slip off from the spin table, because at a certain point the required centripetal force cannot be provided by the frictional force that is available. When that limit will be surpassed, the object is going to start slipping off. And also we also had one other question that if we layered the whole spin table with clay, the clay particles which are close to periphery, they are going to start to slip off earlier, and clay particles which are close to the center, they are going to take more speed to slip off. So this is a similar scenario, that the farther we go above, the more we'll have. But the difference that we have over here is that this is a vertical oscillation system. So you will be using weight for your resultant force only for the upper part of the oscillation, upper amplitude. But for the lower amplitude, the weight will be working against the resultant force, which means your object will be always pressed strongly with the plate. For the lower part, there is no position for, or there is no likelihood for the object to lose contact. It can only happen for the upper part, where the weight is becoming effectively available for maintaining the simple harmonic motion. That's the difference between these two concepts. Acha, tarpor anything else that you tried and need discussion for? আচ্ছা, এখানে আমি আরেকটা জিনিস তোমাদেরকে বলি, সেটা হচ্ছে একটা জিনিস যে তোমরা এসেও দেখছো, সেটা হচ্ছে the formula for stored energy in a spring is given by half k x squared. We all know that. If a spring undergoes from an extension of x1 to an extension of x2, then the amount of change of potential energy, this might be from a small to big, this might be from big to small, I don't care, The amount of change of potential energy is given by half k x1 square minus half k x2 square. Because I'm saying energy, so I could give a modulus sign. What is important that you do, this is the correct expression. What is important that you do not do this half k x1 minus x2 whole square. You do not do this. Be careful not to do this. It's a pretty common mistake. Students do that, but this is the wrong way of doing that. এই ভুলটা যাতে না হয়, স্প্রিং এর ম্যাথ নিয়ে যখনই কাজ করবা এনার্জি ক্যালকুলেশন করার সময় যাতে এই ভুলটা যাতে না হয়। তোমাদেরকে একটা আইকন দেখাই, আমার ডেস্কটপে একটা আইকন। I wonder how many of you would actually recognize this icon. These two grenade icons. Anyone remember? Anyone recognize these two icons? Anyone? No, you don't.
মনে হয় বাট পুরান লাগতেছে অনেক।
Yeah, they are not smooth images. They are pixelated, so they look old, obviously. But these are very old games. Commandos. যারা কমান্ডোস খেলছো তারা জানা যায়, কমান্ডোস খেলা না তারা জানা না, এটা এখন জানার সময় নেই। I'm just showing you that I just downloaded this game.
ওটা তো ছোটবেলার জিনিস।
Exactly. The other day.
অনেক
brings back old memories. আমি আমার ভাই মিলে এখন সবগুলা মিশন খেলার চেষ্টা করতেছি উইদাউট রেজিং দ্য অ্যালার্ম। আগে যেটা করতাম সেটা হচ্ছে যে তোমার অ্যালার্ম দিয়ে তারপর দেয়ালে আড়ালে গিয়ে 3-4 জন দ্বারা একসাথে গান টাক করে ঠাস করে গুলি করে সবগুলা ডাকে এনে গুলি করে মারা তারপর মিশন কমপ্লিট করে ফেলতাম। বাট now we are trying to do the real stealth way. Feels good. আচ্ছা, এখানে আর কোনো প্রবলেম পোলাপান? কেউ কোথাও আটকাইছো কোনো ড্রয়িং এ বা গ্রাফে? এনিথিং? প্রবলেম না থাকলে আমি অন্য টপিক আলাপ করা শুরু করি, পরের টপিক। বা তোমাদের সার্কুলার মোশন ওয়ার্কশিট থেকে কারো কোনো কোশ্চেন আছে?
আচ্ছা
That's right for you.
29 B2 টা দেখাবেন সার্কুলার মোশনের।
কত নম্বর বলছো ইয়ার কোশ্চেন?
Circular motion 29 B2.
29 B2. Okay, beautiful. Zarif, thank you. We'll pick up the circular motion worksheet. I can bring it up right here. Oops, there is this. It's a ব্যাপার না। কত নম্বর কোশ্চেন?
29 B2.
29 B2 দেখতেছি, দাঁড়াও। আচ্ছা, question 29 is about two natural satellites. A moon is in a circular orbit of radius r about a planet. The angular speed of the moon in its orbit is omega. The planet and its moon may be considered to be point masses that are isolated in space. Show that r and omega are related by the expression r cube omega square is a constant. Explain your working. So you just go ahead and do that. You know how to do that. Phobos and Deimos are moons that are in circular orbits about the planet Mars. Data for Phobos and Deimos are shown in figure 1.1. We have the moon, there is a radius of orbit, period of motion. So we have the two radius. B1 will say use data from figure 1.1 to determine the mass of the Mars. Key use data from figure 1.1. What is figure 1.1? Here is the figure 1.1 to find out the mass of the Mars. Acha. Okay, we can actually do that because gmm by r square equals to f r omega square. No, f omega square r, m omega square r. আচ্ছা, এখান থেকে এটা বাই করা যাবে। তারপর বলছে পিরিয়ড অফ ডেমিয়াস এবং এস অরবিটস। আচ্ছা, এই দুটো পারছো তাই না?
জি স্যার।
প্রবলেম হচ্ছে এটাতে, ঠিক আছে। The period of the rotation of Mars, the period of rotation of Mars about its axis is 24.6 hours, slightly bigger than Earth. Deimos is in an equatorial orbit, orbiting in the same direction as the spin of Mars about its axis.
মানে জিওস্টেশনারি তো মানে আমি লিখেছিলাম, কিন্তু মার্কিন হয়তো অলমোস্ট জিওস্টেশনারি। অলমোস্টটা কেন বলছে এটা লিখে না।
আচ্ছা, বলতেছি Deimos is in an equatorial orbit, orbiting in the same direction as the spin of the Mars about its axis. Is your answer to comment the orbit of Deimos? Okay, I'll tell you why this is. Have a look. The period of Mars is 24.6 hours. But the period of rotation about Mars is 7.6 hours. আচ্ছা, এটা বোঝানোর জন্য আমার ক্যামেরা অন করা লাগবে। Hold up. I'll put on some nice dress. এখানে একটা সবুজ ফুটবল ছিল না? আম্মা? হ্যাঁ হ্যাঁ, স্টুডেন্টদেরকে একটা কনসেপ্ট বুঝাবো, আমার একটা বল পাইছি 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 হ্যাঁ পাইছি। Can you get see me? I cannot see myself.
দেখতে পাচ্ছি।
Yes, sir.
আমি আমাকে দেখতে পারতেছি না কেন? আচ্ছা, তোমরা কি আমার স্ক্রিনও দেখতেছো, আমার ভিডিও দুটোই দেখতেছো?
Yes.
Okay, আচ্ছা ঠিক আছে, fine. I cannot see what you are seeing, but I hope it's not as bad as I think it is. So let's have a look. Let's say this is the Mars, which is actually a plastic football of two hemispheres that we have. So this joint that you can see can be considered as the equator. If you have a look at the two different values, have a look. The question says that the period of rotation of Mars about its axis is 24.6 hours, whereas the period of Deimos, how much was this? How much did you get for this number? What is the period of Deimos?
23.6 hours।
23 point? Acha, 23 point something. Let's say 23 hours. Now, what you need to understand, these two numbers are not exactly same. If you want to define a certain satellite to be perfectly geostationary satellite, it has to have the exact same angular speed as the planet, so that it would always appear to be exactly on the same, above the same location of the Earth, above the equator. So anyone observing that satellite would see it in the same position in their sky. I mean, if they are looking up, that satellite will be always located in the same position, because they will not move with respect to the Earth. With respect to Earth, they are stationary. Now, that's not the case for Deimos, because the spin of Mars is taking 24.6 hours, whereas the orbit of Deimos is happening at 23 point something hours, 23 or 22.
23.
23 point something hours, which means every 24 hours this Deimos would be lagging a little bit. For example, whenever this thing would have covered, Deimos would require 23 hours to make one full rotation, whereas the Mars would require 24 hours to make one full rotation. So who will make rotation earlier? Who will complete one full rotation earlier? The one that takes less time. Think about it.
Yeah.
Mars goes around its axis in 24.6 hours, whereas Deimos goes around the equatorial orbit in 23 point something hours, which means Mars would be moving a bit faster compared to the rate of movement of the Deimos would move a bit faster compared to the rate of movement of the equator. Equator সার্কেলটা যে রেটে ঘুরবে, ইকুয়েটরের এই সার্কেলটা যেই রেটে ঘুরতেছে, ডেইমসের অ্যাঙ্গুলার স্পিড তার থেকে একটু বেশি হবে, ঠিক কি না?
Yes, sir.
If Deimos had the exact same period as the orbit period of Mars, then we could call it perfectly geostationary. But that's not the case, because it has a slightly smaller time period, which means it's a bit faster. But since it's in equatorial orbit, so it is almost geostationary. Make sense?
Yes, sir. Thank you.
তারপর anything else? আচ্ছা, আপাতত আমাদের আর কোশ্চেন দেখা যাচ্ছে না। যারা ওয়ার্কশিট করছো তারা হয়তো প্রবলেম সব বলে ফেলছো। যারা ওয়ার্কশিট করো নাই, বাই ডিফল্ট দে আর গড লাইক পিপল, দে ডোন্ট মেক মিস্টেক্স বিকজ দে ডোন্ট ডু ওয়ার্কশিট. I hope you come out of that cycle and do your worksheets, and if you have problems, please feel free to share. And if you did your worksheets and if you really didn't have any problem, you're still godlike people because you didn't do any mistakes. My congratulations to you. আমি নতুন চ্যাপ্টার শুরু করব. I'll take a small break, 5 minutes, and we'll start a new chapter. আমি থার্মাল ফিজিক্সের ফার্স্টে কিছু কনসেপ্ট আমাদের সাথে আলাপ করব আজকে। আসতেছি।